We are going over the exercises, solutions to the exercises from the previous lecture. So we were given two parallel lines, a transversal. We wanted to find the angles that are 60 degrees. That's 1, 4, 5, and 8. 1, 4, 5, and 8. And we wanted to find the 120-degree angles. That's, oops, I have too high now. That's 2, 3, 6, and 7. 2, 3, 6, and 7. And then we had a pipe whose outer diameter was, whose outer diameter, where am I? Oh, come on now. So we had a pipe. The outer diameter was 3¼ inches. The thickness of the pipe was 3/8. What is the radius of the inside circle? So we had we converted 13/8, and we took 1/2 of this figure, which is 13/8, and that's 1 5/8 inches. The inner radius was the difference between the outer radius and the thickness. The outer radius, 1/2 the diameter minus the thickness, is the inner radius, which is 1 1/8 of an inch. Okay, you got that? Then we want to do chapter 31, I think. We wanted to find the perimeter of this rectangle. That was 2 times 18 plus 14. 2 times 18 plus 14, which apparently is 64 feet. And then, what is the perimeter of the following figure? You can go this way. You don't have to cut the corners here for the perimeter, not area, perimeter. So perimeter is 2 times 30 plus 22. 30 and 22, 52, so 104. There we go, 104. And you want to look at that quickly? If you had gone the way that we normally do, in other words, just follow the perimeter, you go through the cut, you add all these numbers, you also get 104 feet. Then, what is the circumference of a circle of radius 10 feet? And it is 2 pi times the radius. So 2 times 10, 20 times 20 times 3.14, or 10 times 6.28, 62.8 feet. And then you should have come up with that number, so you shouldn't have too much to copy. Find the number of feet needed to fence the following. You have 15 plus 8 plus 15, and 2 pi r. R is 4, but that's only half a circle, so 1/2 of that. So 15, 2 times 15 plus 8 plus 2 pi r, and 1/2 of that. I got twice this, that's too much. This should be only 4 pi, not 2 times 4 pi. So your answer should be a little bit less than that. About what? About 58, 59 feet, something like that. And then we wanted to find the perimeter of the following figure. And we are also given that the fence around is 53, not 50, 53 feet. So you have 10 plus 10, plus this is a full circle, 1/2 here, 1/2 here, 2 pi r, which is pi times h, the diameter is h, and that should give you, you subtract the 20, you divide by pi, about 28 feet. Did you get about 28 feet? If yes, wonderful. If not, take another look. Did you go wrong or did I go wrong? Or did we both go wrong? That's a possibility also. And that's the end of this one. Then we have 32. How many tiles size 1 by 1 can be laid in a rectangular kitchen that measures 20 by 15 feet? Well, 20 times 15 is 300 square feet, so 300 tiles. What is the area of the following figure? You can make it a full rectangle from which you cut out a corner, or you put a line here, or a line here, or a line here, and do the individual rectangles. The way I did it, I took the total, which is 40 times this measure, which is 18 and 15, 33. And from that, I subtracted 19 times 18 square feet. There we go. So it's 1,320 minus 342, which is supposed to be 978 square feet. Now, no matter which way you did it, you should get the same answer. If you think I'm wrong, do it in 2 or 3 different ways and see if you come up with your answer. The area of a circle is pi r squared. What's the area of a circle whose radius is 20 feet? Well, pi r squared, 3.14 times 400, about 1,256 square feet. Okay. So pi times 20 squared, pi times 400, about 1,256 square feet. And then we want to go to gallons of paint. You want to paint an area of shape below, the shape below. 1 gallon covers about 350 square feet. 1 gallon of paint costs $28. How much money do you have to spend? This is the figure that you want to paint. So the diameter is 15, the diameter is 30 feet. The radius of the semicircle, not full circle, is 15 feet. So you got the area, which is 30 times 40, and you got pi r squared, 1/2 of that because you have only a semicircle. So 1/2 pi r squared, which is 1,200 plus approximately 706.5, for a total of 1,906.5 square feet. Do we agree with that? Okay. I want to leave it up for a few seconds. You may want to copy some of this. If you had the PDF, you wouldn't have to copy. You could take notes, you could make corrections quickly. But I'll assume that some of you don't have the PDF. Okay, I'll go on. How many gallons of paint do you need? Note that we work with square feet, dollars, and gallons. I know 1 gallon per 350 square feet. I know the total square feet that we got previously, which gives you 5.5 gallons. Now, you cannot buy 1/2 gallon, you have to buy 6 gallons. And the cost is 6 gallons times $28 per gallon. The gallons drop out, the units, you're left with dollars. That's how you know that you multiply, you don't divide. Use the units. The units are user-friendly. The units really help you. So I came out with $168. Then we wanted to find x if the area of the following geometric figure is 560 square feet. So the square feet is given. The length of the rectangle, this is a rectangle surmounted by 2 semicircles. The length of the rectangle is not given. Square feet. We have 20 times x. We have 20 times x for the area of the rectangle plus the area of the circle, which is pi times r squared. pi times 10 squared. That's 314 plus 20x. Subtract 314 from 560. You get 20x, which is 246. And if you divide both sides by 20, you should get, ooh, I don't like this. If you divide 200 by 20, you should get about 10. This figure is not correct. I don't know where that figure came from. But if you will let me do this quickly, we are not supposed to use calculators, but I need an answer very quickly. I have 246 that I divide by 20, and I come up with 12.3. I see what's happening. There's an extra 2 that came in here. That 2 should not have materialized. The answer is 12.3. And then find the area of a trapezoid ABCD. If we know that the height is 10 and the bases are 25 and 35. The base is 25, the base is 35, and the height is, what did I just say? The height is 10 feet. Okay, that should have been given up here. So, yeah, it's given down here. It's not part of the solution. Cross out the solution here. The solution starts here. So we have height, which was 10 feet right here. We have the average of the two bases, which will give us 30, and the square feet, the area is 300 square feet. And so much for that. We continue with chapter 33 about volume, and this video corresponds to section 11.4 volume, similar triangles, 11.5, 11.6, square roots, and the Pythagorean Theorem. So I'll try to keep within an hour total. Basics. The area of a polygon is a measure of the inside in 2 dimensions. The volume of a solid is a measure of the inside in 3 dimensions. Like what is the quantity of air in this particular room? How many boxes, 1 by 1 by 1 foot, could you stack in this room if you know the measurements of the base, the length, the width, and the height? Okay. Volume can also be a measure of a liquid confined to a solid, like a soda can. How much soda do you have? How many ounces? So that's volume. And the volume of the can is 3-dimensional. You can go up and down. You can go right and left. You can go forward and backwards. 3 dimensions. Let's begin with a story about the local tyrant who contracts a Greek polymath, Archimedes, to detect fraud in the manufacture of a golden crown. Now, why do I have this here? Because it's related to volume. Said tyrant, by the name of Hiero, suspects his goldsmith of leaving out some measure of gold and replacing it with silver in a wreath dedicated to the gods. Oh, would the gods be happy these days with the price of gold? Archimedes accepts the challenge and, during a subsequent trip to the public baths, realizes that the more his body sinks into the water, the more water is displaced, making the displaced water an exact measure of his volume. Because gold weighs more than silver, he reasons that a crown mixed with silver would have to be bulkier to reach than the same weight as one composed only of gold. Therefore, I lost my place, therefore it would replace more water than pure gold, which is the counterpart. Realizing he has hit upon a solution, the young Greek math whiz leaps out of the bath and rushes home naked, crying, "Eureka, Eureka!" Or translated, "I have found it, I have found it." Nice little story. If you want to read more, go to this particular website, and you want to copy it, be my guest. http://www.scientificamerican, one word, no spaces, .com/ so www.scientificamerican.com/article.cfm (ID) equals factor, that's FACT. I have a dash here, OR, and another dash, fiction dash Archimedes. So fiction dash ARCHIMED, like David E. Okay, we discussed area as a measure of number of 1x1 unit rectangles in a bigger rectangle, so squares in a rectangle. We can discuss volume as a measure of 1x1x1 units. So instead of a tile 1x1, you have a box 1x1x1, which contains cubic feet. Why cubic? Because you have 3 of these. Square, you have 2 of these, and one-dimensional, just 1. Here is my rectangular box. You have 10 feet on the length of the base, you have 3 feet on the width of the base, and you have 5 feet in height. And I show you with these dotted lines how many of the packages, 1x1x1 boxes, you can have in here. So on the bottom floor, you have 10 times 3 or 30, and how many floors are there? 5. You should have 30 times 5 or 150 boxes that you can store in here. All the boxes are the same size. Does this make sense? That's a measure of volume. The more boxes you can store, the more volume you have. Or vice versa, the more volume you have, the more boxes you can store. Now, isn't that a nice box? This is 3-dimensional. This looks like it is slanted. It's not supposed to be. It's a box. The top is horizontal. The 4 sides are vertical. So this slanted part is in 3D. We can place 10 times 3 boxes on the bottom, and we are given 5 floors. I just went over that. So if we want the total volume of a rectangular parallelepiped, I haven't written it, so a rectangular box, you have the width by the height by the length. Length times width times height. Length times width times height. This x is times. I could have made it a dot. I could have put just LWH without a symbol between the LW and between the W and H. That would have meant multiplication. Length, width, height, length times width times height. Now, how about a cylinder? What's a cylinder? It's like a can of Coke. Find the volume of a rectangular cylinder. That doesn't make sense. Of a, what am I trying to say? A vertical cylinder. I forget. Okay, a rectangle, a cylinder that looks like a can of Coke. The base is a circle, pi r squared. The top is a circle, pi r squared. And you multiply the base by the height. That gives you pi r squared times h. That's the volume of a right circular cylinder. The word was right. So right, you have the axis that goes in the middle, and that is perpendicular to the base. Okay, so it's straight up. It's not leaning on the side. A circle is a collection of all the points in the plane in two-dimensional, points equidistant from a fixed point called the center. A sphere is a collection of all points that's in three dimensions equidistant from a fixed point called the center. So the circle and the sphere are essentially the same. One is two-dimensional, one is three-dimensional. That's the only difference. The points on the difference of the points on the surface of a sphere are the same distance from the center, all the points, just like we did for a circle. The volume of a sphere is 4/3 pi r cubed. Now that's nice for you to know. You don't have to memorize it. If you ever want to know the volume of a sphere, there is the formula. As an example, we have a three-tier wedding cake that corresponds of three rectangular parallelepipeds with square bases measuring 12 inches on side for the lower layer, 9 inches on the side for the middle layer, and 6 inches on the side for the top layer. Parallelepiped means just a box. All the sides are parallel. A rectangular parallelepiped. Okay? A box like we had been using before. Don't get confused with that. Now the cake is to feed 150 guests, and each guest gets a slice which measures about 8 cubic inches. What is the height of each layer? So you have 3 boxes, one on top of each other, and the volume of the total cake with h height is the following. Each layer is, there are 150 guests, so 150 slices. We have 8 cubic inches per slice. Note the slices drop out, the units are held for. That gives us 150 times 8, or 1,200 cubic inches. Okay? We need to come up with a volume of 1,200 cubic inches. Now the volume of the 3 boxes is base. Base is a square, so 12 times 12 times the height. The next one is a base that is 9. The next box is a square on the bottom, so 9 times 9 times h. And the last layer, the topmost layer, is a square on the bottom, a square, 6 by 6, times the height. The height can be factored out. The height can be written in front. And that gives you 144 plus 81 plus 36. 144 plus 81 plus 36 times the height, or 261 times h cubic feet. And that is supposed to be 1,200 cubic inches. And we have 261 square inches. Where does that come from? Comes from right here. So the height is the total cubic inches divided by the square inches. That gives us just inches. And the height of the box, the height of each tier, is supposed to be 4.6 inches. Now, wasn't that a nice practical problem? Did this make you hungry? Enjoy. Enjoy your food for thought. Then we have a grain silo, which consists of a cylinder measuring 10 feet in diameter and 30 feet in height. It is surmounted by a hemisphere, that's half a sphere, whose radius is 5 feet. Find the volume of the storage of the bin. Then find, forget about the G, then find the weight of the grain in a completely filled silo if you have 48.18 cubic feet weight per 60 pounds. So 60 pounds of grain take up about 48.18 cubic feet of space. The volume of the cylinder is given by pi r square h. R is the radius of the base, h is the height of the silo. The volume, as I said, is 4/3 pi r cubed. So the volume is pi times r squared, that's the base, times the height 30, 2,355 cubic feet. Why cubic feet? Feet times feet times feet. So cubic feet. That was just the silo, just the cylindrical part of the silo, just the Coke can or the soda can equivalent of the silo. And then the volume of the hemisphere, the volume of the total sphere is 4/3 pi r squared, about 533 cubic feet. And again, I was not careful. We just have a hemisphere. I made it the total sphere. So this number is twice as big as it should be. The total then should be 2,355 plus 1/2 of 533. A little bit less than this, about 2,500 in that neighborhood. If this was the figure, then how would we find the weight? We have 60 pounds per 48.18 cubic feet. The cubic feet drop out. We divide these two numbers. We multiply by 60. Should give us about 3,600 pounds. And remember, this is a little bit too big because that figure is too big. So you get the correct figure. Then I present you with some exercises. Again, you have a 3-tier wedding cake over 3 rectangular parallelepipeds, so 3 rectangular boxes with square bases also, and the bases are 16 inches for the lower layer, 12 inches per side of the middle layer, and 8 inches per side of the top layer. And all the layers are the same size, the same height, I mean. Otherwise, I couldn't do that problem this simply. And the cake is to feed 200 guests. Each guest gets a slice that is about 8 cubic inches. What is the height of each layer? Oh, don't tell me I give you the solution here. The height of each layer, I give you the solution. Well, I wasn't supposed to. But since we don't meet again, well, it's not too bad. I'll give you the solution to the problems later at the end. A grain storage silo consists of a cylinder that is 20 feet in diameter and 40 feet high. It is surmounted by a hemisphere of radius 10 feet. Radius 10 feet. If I had said radius in the other one, the figures are correct. If I said diameter, the figures are not. Let me try to remember that I said radius here. Okay. We still have 48.18 cubic feet per 60 pounds of grain. So we have the volume, which is, I am giving you the solution. So this is the formula for the volume of the total sphere. Oh, that's where I stopped. I didn't give you the solution. I just give you enough so that you can work the problem. Now we are interested in chapter 24, identifying corresponding sides of similar triangles. Okay. You have your eye is here. You have a triangle, a small triangle, a big triangle, and you place the big triangle, the two triangles are similar. So similar means they have the same measurement for the angles. If this is 60 degrees at B, this is also 60 degrees at B prime. If this is 100 degrees at A, this is also 100 degrees at A prime. And if at C you have whatever is left for 180 degrees, I think that's 20. You have 20 degrees here at C and 20 degrees at C prime. So if you move the big triangle far enough out, there is a position where you go from seeing two triangles, if this is too close, to seeing exactly one triangle. This one exactly overlays that one. Or if you keep on going, you'll just see this triangle. That one is completely covered up. You don't see it anymore. I want to stop when this one exactly covers that one. Then I will have ratios that are the same. The side AB is to the side A prime B prime, as BC is to B prime C prime, and as what is left, AB is to A prime B prime. Or if I haven't mentioned it yet, BC is to B prime C prime. The ratios are the same in similar triangles. Okay. It looks like the big triangle is 5 times the small triangle, so the ratios should be 5 if you go one way, or 1/5 if you do the reverse. Similar triangles are useful beyond belief. They are the starting points behind geometry and a whole collection of trigonometric identities, which means equations true for all values of the variables. That's an explanation of identities, not trigonometric identities. Forget about this. This is just a particular science, which is very important. So an identity is an equation that is true for all values of the variables, not just 1 or 2 or 10. We want examples. Suppose you have the sun, which creates a shadow for a tree. The shadow of the tree is 20 feet, and the shadow of the boy is 3 feet high, the shadow of the boy is 2 feet. These two triangles are similar. The same angle here, right angle here, right angle here. The same angle in the small and the big triangle, and that leaves the same measure for this angle and that angle. So the triangles are similar. So you can make ratios. You are interested in H. H is to 3 as 20 is to 2. And when you crank that out, you find that H is 30. Okay? So H is to 3 as 20 is to 2, and then H is 30. So the tree is 30 feet high. Oh, we have a beam. Oh, that beam is awfully big. You may not see the whole thing. We have a beam that goes from A to B, and it goes from one corridor. This is one corridor. That's a corner. That's another corridor here. And in a particular position, we want to find the length of the beam. So in a particular position, we know that this distance is 12. This distance is 30. The length of this corridor is x. From here to here is x. And the length of this corridor, not the length, the width of this corridor is 5 feet. The width of this corridor was x feet. And this is 12 feet. We are interested in finding the length, the width of the second corridor. Okay. This is about the same. It looks like it's a little bit smaller. We have 30 feet here, 12 feet here. Let this be x. From here to here, let that be x. Then this is the total 12 minus x. We have this triangle, which is similar to that triangle, y. We have a right angle here. We have a right angle here. This angle is congruent to this angle, and so the third angles must be congruent also. Then we set up a proportion. We have AC is to CD. AC is to CD, as AE is to BE, as AE is to BE, This is BE. That's 30 feet. I wish I had not made it that big, but it's a little late now. So if you draw this and you figure out you have 12 minus x is to 5, as 12 is to 30. You cross multiply, you get 30 times the quantity 12 minus x, which is 5 times 12 or 60. You distribute the 30, you get 360 minus 30x. Don't forget the 30x. You subtract 360 from both sides, that's negative 300, negative 300. So negative 30x is negative 300, or x is negative 300 over negative 30, or 10 feet. The second corridor is 10 feet wide. You want to look at some of this again? Okay. AC is to CD as AE is to BE, which means 12 minus x over 5 is 12 over 30. You cross multiply, you get 30 times 12 minus x, which is 5 times 12. You get 360 minus 30x, which is positive 60. You subtract 300 from both sides, that leaves you with negative 300 here. And finally you divide and you come up with 10 feet. Then we have exercises, I guess the same type of problem as the previous one. Now instead of a boy who is 3 feet tall, we have a boy who is 4 feet tall and casts a shadow of 3 feet rather than 2 feet like previously. And we have a beam that goes across a corridor. Oh, I didn't. You're supposed to do this on your own. The width of this corridor is 5 feet. The width of that corridor is to be found. That's x. This dimension is 15. And the beam cuts back on this wall a distance of 40 feet this way. And then find the width of this corridor. Find x. Nice little problem. I'm interested in chapter 35, which is square roots and the Pythagorean Theorem. In the basics, we have seen how to square a number. The square of 6 is 6 times 6, so 6 squared. Where there is squaring, there must be unsquaring. My own word, unsquaring. Unsquaring is really called taking the cube root, taking the second root, the square root. If you had a quantity raised to the third power, you would take the cube root for uncubing. So numbers like 1, 4, 9, 16, and so on are called perfect squares. 0 can be written as 0 squared. The square root of 0 is the square root of 0 times 0, which is just 0. The square root of 1 squared is 1 times 1. The factors, the pair of factors, 1 times 1 comes out as a single 1. 4 is 2 times 2. So the square root of 4 is the square root of a single 2. Square root of 4 is 2. Square root of 9, square root of 3 times 3 is a single 3. Square root of 16, square root of 4 times 4 is a single 4. Square root of 25 is just 5. Square root of 100 squared is just 100. Because 10,000 is 100 times 100. That's square root. What is the square root of 81? 81 can be written as 9 times 9, comes out as a single 9. You want to check yourself when you raise 9 to the power 2, so 9 squared. You should get the radicand, which is a quantity under the square root sign, which is 81. You could also have written 81 as 9 times 9. which is like the square root of 9 times the square root of 9, which is 3 times 3, which is 9. So you can say the square root of 81 is one of the pair, that's 9. Or you can say 3 times 3, which is also 9. And we have just discovered, if we take the square root of a product, we can take the square root of the individual factors, and the product of that will be the same as the original starting point. The square root of 36 should be 6, because 6 times 6 is 36. The square root of 64 is 8. The square root of 49 is 7. So the square root of 64 over 49 is 8 times 7. What is 8 times 7 times 8 times 7? 8 times 8, 64. 7 times 7, 49. So that works, doesn't it? The square root of 36 is the square root of 4 times 9, which I can split up as square root of 4 times square root of 9. Works great when you have multiplication. Does not work if you have plus or minus here. Be careful. Sooner or later, lots of people will make that mistake. You can factor out factors. You cannot factor out terms. Terms are quantities added to or subtracted from each other. So we have discovered that the square root of a product is a product of the individual square roots. You want to copy some of that? I may have gone a little bit fast. I guess I could have gone a little more slowly. This is our last chapter, I think. Yeah, I think so. And we still have about 16 minutes left. I could have gone more slowly. So 81 is 9 times 9, comes out as 9. 36 is 6 times 6, comes out as 6. 64 over 49, the square root comes out as 8 over 7. And the square root of 4 times 9 is the square root of 4 by itself times the square root of 9 by itself, because it's 2 times 3, and 2 times 3 is also 6, like we had 6 up here. As I said, be careful. Why do you think the square root of this pair plus that pair is not a single 3, a single 4? This side is 7. What is that side? If you said 5, you would be correct. And why is it 5? Remember pandas? A long time ago in this course we discussed the order of operations. That's applicable now. P is everything under the square root. So P is not only parentheses, P is a group. And the radical sign holds a group together. Okay. Suppose I tell you that 176,400 is a perfect square. Find its square root. Well, how many pairs of factors can I make up in here? I can see 100. 1,764 times 100. 100 is 10 times 10. So I know there's a 10 that can come out. And what else can come out? Maybe we should think of a prime factorization. So the divisibility tests come in handy. If I were not told that this was a perfect square, I would probably grab a calculator and see what the square root is. We are not using calculators, so I'm not going to ask you what a particular square root is, unless it is a perfect square. Okay, so I'm breaking up. I'm doing branching on 176,400. It can branch out to 100 times 1,764. 10 times 10, which is 2 times 5, 2 times 5. A pair of 2s, a pair of 5s. I know the 2 comes out, I know the 5 comes out. We already knew that the 10 came out. I can divide by 2 because that's an even number. After I divide by 2, that's 882. Still an even number, so a 2 comes out. There's a pair of 2's, another 2 comes out. I'm left with 441. Cannot divide by 2 anymore, can divide by 3. Yes, the sum is 9. Or if the sum is 9, I can divide by 9. So this is 9 times 49, that's 441. And the 441 breaks up as I said, 949. The 9 breaks up as 3 times 3. The 49 is 7 times 7. A pair, a pair. Oh, aren't we glad we got pairs of factors? So what do we have? 2 times 2 times 2 times 2. That's 2 pairs of 2's. So 2 times 2 comes out. 5 times 5, 5 comes out. 3 times 3, 3 comes out. 7 times 7, 7 comes out. I circle the prime numbers. So I have 2 to the 4, 3 square, 5 square, 7 square. 2 to the 4 is 2 square times 2 square. 2 square comes out. 3 square comes out as 3. 5 square comes out as 5. 7 square comes out as 7. This is the square root of that big number, 176,400. Oh, is that really a big, big number? Would I give you something like this on a test? Oh, yes, I would. I want you to be sure that you remember prime factorization and how to do this right here, not just guess small numbers. So that is supposed to be 420, and I check 420 squared is indeed 176,400, which approximately what is the square root of 55? I don't want to know what it is exactly. I don't have a calculator, but it is between two consecutive numbers. It's between the square root of 49 and the square root of 64, so between 8 and 9. 155 is between 144. 155 is between 144 and 169. That's 12 square, 13 square. So that's between 12 and 13. I made a little table here. In this column you have the whole numbers. In this column you have the squares of the whole numbers. The square root of 5. 5 is between 4 and 9. The square root is between 2 and 3. Square root of 55. 55 is between 49 and 64. The square root is between 7 and 8. 155 is between 144 and 169. The square root of 155 is between 12 and 13. See how that works? Neat. Then we go into the Pythagorean theorem. Pythagoras, whatever I tell you now was known before Pythagoras, but Pythagoras is apparently the first one who made a formal proof. That's why his name goes with that. You can read a bit of history. I've given you here, you can read it, and I've given you where to find that. Now, what is the Pythagorean theorem? Well, first of all, what's a theorem? It's a statement that you can show is true based on what you assumed and what you developed so far. In the Pythagorean theorem, you have a right triangle. The two legs are the shorter sides of the right triangle, and the hypotenuse is the longer side. The sum of the squares of the legs is equal to the square of the hypotenuse. A triangle with legs 3 and 4 and hypotenuse 5 is such that 3 squared plus 4 squared is 5 squared. 9 plus 16 is 25, and 5 squared is also 25. Then I wanted to find a baseball diamond. A baseball diamond is a 90 by 90 square. The diagonal is the square of the diagonal, that's the hypotenuse, is 90 square plus 90 square, which gives you 16,200 for c square. C is the square root of that, which is somewhere between 120 and 130. Or if you refine that, you come out with about 127 or 128 feet. And then I wanted to give you some exercises. Find consecutive numbers that bracket square root of 7, square root of 77, square root of 177. So 7, 7, 7, and 177. And then find the square root of, that 36 is not right. I bet you that should have been 1,600. That 36 should have been 1,600. Now I'm telling you that 11,025 is a perfect square, and find out what that perfect square is. Find out what brackets 7, 17, and 177. And then you have a park that is a square that has 700 feet per side. You have a walk that is like a diagonal. What is the length of that walk? So a square, 700 by side. What is the diagonal? Now I want to give you the solutions because we don't meet again. So in the first chapter that we covered today, we had a 3-tier layer, and I got the answer by saying that I have 1,600 cubic inches to work with. And if I want the volume of the 3 layers, it is about 464 times the height of each layer. That's 16 square plus 12 square plus 8 square, all multiplied by h. And what is the height of the layer? The total volume, the total number of cubic inches, divided by 464 square inches, which is about 3.5. So 3.5 inches for the height of each layer. The silo had a volume of about 12,560 cubic inches. And the volume, I wasn't careful. Oh yeah, I was careful. I think the radius was 10. If the radius is 10, this is correct. No, it is not. Because this is a total sphere, we just have a hemisphere, I should take 1/2 of this number. So the total is supposed to be a little less than 14,000. You multiply the correct number of cubic feet by 60 pounds per cubic feet. The cubic feet drop out. We have 60 pounds volume. We have 60 pounds weight per 48.18 cubic feet. And this came out to be about 17,800 pounds. Your true answer is a little bit less than that because the cubic feet are less than what I give you here. Oh, that's too bad. We have the boy who is 4 feet, casts a shadow of 3 feet, and the height is 230. The height is to 4 as 30 is to 3, or the height is to 30 as 4 is to 3, the same thing. So I came out with a height of 40 feet. The pole is 40 feet high. And then we have the beam. In the equation of the beam, we have 15 minus x over 5, which is 15 over 40. And when you crank this out, you're supposed to get about 13 1/8 feet per width of that second corridor. And then the square root of 100 is 10. The square root of 1,600 is 40. The square root of 11,025. 11,025 is 3 squared times 5 squared times 7 squared. So 3 times 5 times 7 is 11,000. Is 105, whose square is 11,025. Consecutive numbers for 7. 177 and 17. 7 lies between 4 and 9, so square root between 2 and 3. 77 lies between 64 and 81, so square root between 8 and 9. 177 lies between 169 and 196, so between 13 and 14. And here the walk of the parallel of the diagonal of the square part is, I came out with approximately 700 times square root of 2, which is about 990 feet. Now, I used a calculator to find the square root of 2. Without calculator, you could bracket it between, whatever it is. I'm running out of time. Now, we are just about done. I want to do one more thing. These videos were made possible with the cooperation of Ty James of Coastline Community College, Scott Kecken, West Los Angeles College, where I teach full-time, and I'm proud to teach full-time there, and Jerry Hine of Coastline Community College again. And I thank you for giving me the opportunity to join you. I don't know how to spell my name. This is Henry Feiner with an I. So if you enjoy what you have, in spite of a few misprints, send me a note. I'd be glad to hear from you. And bye-bye.